Welcome. Today we are going to discuss about some other important features of the VT graph, and you perhaps already have understood what a VT graph is, and you must be already having in mind that a VT graph can be constructed for a body in uniform motion and for a body in non-uniform motion as well. You already know that a VT graph is actually a graph in which we have the time on the x-axis actually here, and we have the velocity on the y-axis. And this VT graph gives us the relation between the velocity of a body in the time interval wherein the body undergoes motion. Today we are going to discuss about an important property of this graph, and the property of this graph that we are going to talk about is the following. A VT graph has an area under it, and the area under the VT graph gives us the displacement of the body in that particular interval of time. Now, what do we mean by this? Suppose if we have a VT graph of this nature. Suppose we have a VT graph of this nature. In such a VT graph, we can say that the time is as follows. This is 1 second, 2 second, and 3 seconds. So the body has traveled for 3 seconds approximately, and the body is traveling initially with a velocity of 1 meter per second, and then it is traveling with it has increased its velocity to about 2 meter per second, and then so on. So here suppose it has increased its velocity to 2 meter per second, and then here it has increased its velocity to 3 meters per second, and it has traveled through a time period of say 3 seconds. Now the area under this graph gives us the displacement of the body in that particular interval of time. So if we are interested in calculating the displacement of the body in these 3 seconds, what we actually have to do is we have to calculate the area under this graph, that is the area of this portion over here. This portion is the area under the graph, and as you can see quite well enough that this area is actually a trapezium. A trapezium has two parallel sides, and it is a four-sided quadrilateral, so it has got two parallel sides, and the area of this trapezium, that is area under the VT graph, will give you object. Let us calculate the area under graph which we are seeing right over here. So the area of this graph is the area of the trapezium, and the area of the trapezium is the sum of the parallel sides. Let me put that down. So area of the trapezium is the product, okay, I'll just write it in this way, equal to half into the sum of parallel sides into the height, that is the distance between the perpendicular distance between the two parallel sides. So here we have half multiplied by the sum of the two parallel sides. The sum is, this side is 3 and this side is 1, so the sum of the sides is 1, 3, and the height is the perpendicular distance between the two sides, that is also 3, so we put down 3 over here, and this gives us 4 times 3, that is 12, and half of 12 is 6. So the displacement of the body is 6 meter. Now you may have a question like this also, that suppose we have a VT graph of this nature like this, and this is a VT graph, so I'll put that V over here and T over here, and this VT graph has a structure like this. this part of the graph, since it is parallel to the time axis, it represents uniform motion of the body, and this part of the graph which is oblique, it represents positive acceleration. So suppose this is 1 second, okay, this is 1 second, and this is 2 second, okay, so this is 1 second and this is 2 second, and this is 1 meter per second. Then we have, this is 1 meter per second, this is 2 meter per second, here this is 2 meter per second, and this corresponds to say 3 meter per second. So now the question is, what is the displacement of the body? So for the first 1 second, it is traveling with uniform velocity of 2 meter per second, and after that for 1 second it is accelerating with increasing velocity. So what is the displacement of the body during this time interval? We find out the displacement in the same way, and the displacement is as follows. The displacement will be area under this VT graph, and the area under this VT graph will be actually the area of this rectangle over here, this rectangle, and also the area of this trapezium over here. So the sum of the area of this rectangle and this trapezium will give us the area under the VT graph, and that will give us the displacement of the object. So let us calculate it for now. So we have the displacement equal to the area of the rectangle, that is length into breadth of the rectangle, plus we have this the area of the trapezium. That area of the trapezium is nothing but the half into sum of the parallel sides into height. So just copy that and we'll just place it here, right? We'll just place it. So what we have now is L into B. L into B will be length we can take as 1, and height, breadth we can take as 2. So it will be 1 into 2, that is the area of the rectangle there, all right, and the area of the trapezium, as the formula gives us, it will be 1 by 2 times the sum of the parallel sides. The parallel sides are this and this, so sum of these two sides, this one is 3 as you can see from here, and this one is 2, so we have 3 plus 2, that is 5, and the distance between these two sides, this is the distance, that is 1. Okay, so this gives us 1 and 2 multiplied together gives us 2, and this gives us 5 by 2, that is 2.5. So the total is 2 plus 2.5, that is 4.5 meters. So that is the displacement of the object in this time period, total time period of 2 seconds. So today we have discussed about another important property of VT graph, and we have seen that the area under the VT graph gives us the displacement of the object. We shall come back again in a later video to discuss about some other topics. Thank you.